Hello and welcome to my presentation. Today I'm going to explain the motion of a skateboarder. To illustrate this motion, I filmed my little brother on his skateboard. I instructed him to just push off once and then continue to ride down the sidewalk until he stopped. Here is a dot diagram illustrating the motion from the video. As you saw, the skateboarder continued to slow down, showing negative acceleration as each second passed. This negative acceleration is shown more clearly in this chart. You see that with each second, the skateboarder covers less distance. In the first second, he was able to cover 2.5 meters, but between 4 and 5 seconds, he only covered 0.3 meters. This position versus time graph shows us that he was not moving at a constant speed based on the slope of the line. He starts off quite fast and then slows down more and more with each second. Here is a chart of his change in velocity over time. Again, you can see the rapid decrease in velocity with each passing second. In this velocity versus time graph, you can see the steep decrease in velocity after the first second. It decreased by about 1.4 meters per second. And from there, the velocity continues to decrease, being about half of what the velocity was in the previous second. For acceleration, I thought it would be easier for graphing purposes to calculate the skateboarder's average velocity. So I already had his final velocity, which was 0.3 meters per second, and his initial velocity, which was 2.5 meters per second. And the total time it took was 5 seconds. Formula for acceleration is final velocity minus initial velocity over time. So to solve, I did 0.3 minus 2.5 divided by 5 to get an acceleration of negative 0.44 meters per second per second. And this acceleration versus time graph shows that acceleration of negative 0.44 meters per second per second. Next, I found the forces acting on the object to help explain the rapid decrease in velocity. So what I was given was his mass, which was 44.8 kilograms, and this is the mass of my brother plus his skateboard, and the acceleration of gravity, which was 9.8 meters per second. Formula for force is mass times acceleration. So to solve, I did 44.8 times 9.8 to get a grand total of 439.0 newtons. In this force buddy diagram, you can see that the force of gravity and the normal force is balanced, which keeps him flat on the ground, but that the force of friction is significantly greater, which is what was slowing him down. Then I finally found the total energy that it took for him to ride his skateboard. I was given the force, which was 439.0 newtons, and the distance, which was 5.5 meters. And then the formula for work is force times distance. So to solve, I did 439.0 times 5.5 to get his total energy of 2,414.5 joules. In conclusion, this experiment is an example of Newton's first law, which states that an object in motion will stay in motion unless acted upon by an unbalanced force. This law applies most because the skateboarder would continue moving with a constant velocity if it was not experiencing friction from the sidewalk. Finally, I have my works cited page, which shows the 2 outside sources I used, along with all the notes I used from my notebook. Thank you.